Okay, we're going to take a look at the transformations of graphs. We're going to look at some key functions. I can't remember how this breaks up. I sliced this into three pieces here, but it is much easier, I think, to self-discover how all this moves. So I have an activity that I probably gave you that shows you how to see what happens. You go into GeoGebra and you just move the pictures around. But in this video, I'm going to just talk you through it in case like you did that activity and maybe you didn't understand. So let's get going. So, okay, so we're starting with the two easiest here. So we have a function and we want to move it vertically. So we want to move it up or down. All you have to do is just add something onto the end of the equation. Let me see if I have, yeah, so here's the cube root function. Okay, looks like this. Now we're going to take that cube root function. If you just add something onto the end, you put something in for x, you crunched it just like you always would, and now if you add something plus 1 on the end, it's going to take your answer and it's going to just move it up 1. So if you want to vertically shift a graph, this is the easiest one. If you add to the final answer, just tack it on the end, or subtract, you can move it up or down. It's completely intuitive, exactly the way that you would think it would have been. So if we wanted to move this one up 20, so I don't know what the function is, but if we had the function, all we'd have to do is add 20. You take the final result, add 20, it's going to just shift everything up by 20. And we could subtract if we wanted to move down. So it's literally just taking the original function and everything that comes out of the function. So here are the output values. We put in those t's, we get these out. We're just adding 20 to every single value. And when we do that, it's going to shift everything up. Now, the point of this, I don't know that the table is necessary. We're going to get the original function. Now, we'd put in the x's. What we get out, we're now going to take away 3 from every one. You don't really need a table to do this, but that's what they're getting at here. So every value of f of x, everything that came out of the machine, is now 3 less. We've just subtracted 3 from every single value you could ever put in there. Let's see. Okay, so we have this function here, the height, and what they're saying is we've moved it to the top of a 10-story building. So I'm just going to take that same function, everything is the same, and we're going to move it up 10. All right, now horizontally, if we want to move it right and left, this is a little bit counterintuitive. It turns out, and again my activity I hope shows you that, it goes the opposite way that you would think. So if I want to subtract 2, so now look that it's happening inside of there, right on the x. So I had the function, well they're using, I don't know, two different ones. Let me do the one I've got here. So if you had x squared, which is what they're doing, let me see, maybe they have a picture. No, they don't. So x squared makes that parabola. If I wanted to do x minus 2, look what I've done. The shift is happening in on the x and the square is still on the outside. Do you see? So here was x, I'm shifting it inside there on the x, and then it's squared on the outside. Now here's where it's counterintuitive. If you take away 2, you would think that moves you back because it's subtraction. It actually moves you to the right. So I will explain why here in just a second. Let me see if I've got any other. Okay, I hope there's better ones in the next section because here's what happens. They want to move it 2 hours later. So they want to move it to the left. So if we want to move left, we actually wind up adding. Here you can see why. So it's built with a minus sign. These shifts are built with a minus. Plus is left and negative is right. Now let me see if it's time to explain this. Hold on, let me get through what they've got here and then I'll explain why this works counterintuitively. So what they're doing now is, and maybe actually the table might help us, they're going to change by taking off 3 from every x. So Yeah, this is the root reason of what's happening. Our new function is going to get the output as if you'd put, so instead of putting, we put in 5, it gets 3 taken away from every one of the original ones, so you wind up getting the output for f of 2. Yeah, I don't think this will make intuitive sense to you here. I'm going to show you on a picture. So basically, the x you put in now gets 3 removed from every single one of them, and so you're going to get an output that's based on a different value. Hold on. Yeah, I don't think that makes sense. Let me show you with this one. Let me see what they've got here. Yeah. Yeah, the table doesn't make sense. So this is probably something that would be better for the next video. But let me show you what's happening. So this has moved to the right. So this is f of x equals x minus 2. So it's right shifts you. Here's why. Suppose I had put in 0. Well, I put in 0 for x, and now I'm taking 2 away from it. I'm actually going to get the value from the old function that was back here. So, hold on, let me put 2 of them on the same one. Okay, so here's the original one. Now, if I put in here, I've got the original function. If I put in 0, I get this spot right here. If I had put in negative 2, I would get this spot right there. So here's what happens. The new one has to put in the number 2 just to get what was at the origin. And it has to put in the number 4 to get what used to happen at the number 2. And it has to put in the number 6 to get what happened at the number 4. So what is essentially happening is it has to go back to the old graph and pull it all forward 2 spots. I don't know if this makes sense. It's difficult to wrap your head around. So again, a minus moves you right, a positive moves you left. But what's happening is the new graph puts in 2, but it needs to get the picture from back at 0. It gets the output from back at 0. So 2 now gets 0, 4 now gets 2, and it grabs it and it pulls it forward. So although it's not intuitive, you put in your x, you're taking 2 away from it. You're actually moving back in time, essentially, and pulling what happened behind you up to where you are now. Now that's a real soft introduction here. That's all we've got so far, and we'll move on to some more of it in our next video.